Namaste, children. Coming to the next chapter, work, power, and energy. We are going to learn the work done by a force, energy, power, kinetic energy, potential energy, and law of conservation of energy. Now, the physics concept of work. In our day-to-day life, we are talking about the term work, energy, and power. But we are doing work. We need energy to do work. He is a powerful man. Any physical or mental activity is termed as work done in general. But according to physics, the meaning of work is entirely different. We will discuss the difference between the term work used in our daily life and the term work defined by physics. The energy is needed to perform many activities like running, walking, playing, singing, swimming, reading, writing, lifting objects, dragging the objects, cycling, fighting. We get energy for all these activities from food. Similarly, energy is also needed by animals to perform many activities. Horses need energy to pull carts, bullocks need energy to plow fields, donkeys need energy to carry loads. Different machines also need energy for their operations. Electric drill, food mixer, electric kettle, television, radio, electric bulb, microwave oven, cassette player, microphone, toaster, electric fan, computer, etc. work only when energy in the form of electricity is provided to them. We also get energy by burning things in the presence of air, that is oxygen. Coal is burnt to heat things. Car engines burn petrol or diesel fuel for their operation. Energy needed to cook food comes by burning coal or gas. Thus, we find that all living things and non-living things need energy. Now, in our day-to-day life, the word work means any kind of mental and physical activity. For example, reading a book, cooking food, walking on a level road with a box on our head, pushing a wall of the house but fails to do so. In all these cases, either mental or physical activity is involved. But in physics, the term work has entirely a different meaning. Now, scientific conception of the work in physics. The work done is a force applied on a body displaces the body in its own direction. In other words, work is done only when a constant force is applied on an object causes the object to move in the same direction as the force applied. That is, the conditions which must be satisfied the work done are a force must act on the body and the body must be displaced from one position to another position. Thus, no work done in all cases mentioned above. Now, coming to the definition of work, work is said to be done by a force on a body or an object if the force applied causes a displacement in the body or object. For example, work done when a box is dragged on the floor from one position to another. In this case, force is applied to drag it on the floor and then the box moves through a certain distance between one position to another position. Examples, work is done when we hit a football. In this case, when we hit the football, force is applied on the football and the football travels a certain distance before landing on the ground. Another example, work is done when a box is lifted from the ground to some height. In this case, force is applied on the box to lift it and the box moves through a distance equal to the height through which it is lifted. Factors on which work done depends. The work done by a force depends upon the magnitude of the applied force. If small force is applied on a body, less amount of work is done. On the other hand, if a large force is applied on the body, more amount of work is done on the body. Thus, W is directly proportional to F, where F is the magnitude of applied force. Next factor is the distance traveled by the body in the direction of force applied. If a body travels a large distance on the application of force, large amount of work is done. If a body travels a small distance on the application of force, small amount of work is done. Thus, W is directly proportional to S, where S is the displacement. Work done by a constant force. Now, work done is said to be when a force acts on an object and the object is displaced in the direction of force. The work done automatically, the work done on an object is the product of the force applied and the displacement. W is equals to F into S. The unit of work is joule. If F is 1 Newton and displacement is 1 meter, then the work done is 1 Newton meter or 1 joule. So, 1 joule is the amount of work done when a force of 1 Newton displaces an object by 1 meter. For example, if a force of 5 Newton acts on an object is displaced through 2 meters in the direction of force, then work done is said to be 10 Newton meter or 10 joules. Now, kinetic work causes change in kinetic energy. So, the units are the same. Units of kinetic energy are joule. Mathematically, kinetic energy is equals to half mv square. But from the definition of kinetic energy, energy by virtue of motion is called as kinetic energy. The units are also equivalent to 1 joule is equals to 1 kg meter square per second square. Now, potential energy is the virtue of an object possessing potential energy is by its position. PE is equals to mgh. Now, force in direction of motion is the work done by a constant force, positive or negative or zero. Let constant force F is applied on a wooden block placed at a position on a smooth surface. Suppose the block moves in the direction of applied force, then the work done is said to be positive. Thus, work done on the block by a constant force is equal to the product of magnitude of the applied force and the distance traveled by the body. The force applied is at an angle with horizontal direction. That is, F is the force applied on a block at an angle with the horizontal direction. The component of force is in the horizontal direction. Then W is equals to Fs cos theta. If the force component is in vertical direction, then W is equals to F sin theta. Let the block moves horizontally and occupies another position so that it travels a distance s horizontally. Since F sin theta does not produce displacement in the block in the upward direction, so the only force which displaces the block is only in F cos theta. According to the definition of work done, W is equals to force applied into distance traveled by the body, that is equals to W is equals to Fs cos theta into product of the magnitude of the displacement and the force in the direction of the displacement. Positive work is done if theta is equals to 0 degrees, that is the force acts in the direction of the displacement. W is equals to Fs cos 0. W is equals to since cos theta 0 is cos 0 is equals to 1, so work done is known as positive work done. Thus, work done by a force on a body is said to be positive when the body is displaced in the direction of force applied. Then, for example, when a coolie lifts a box from the ground to put on his head, work done is said to be positive. In this case, coolie applies a force on the box in the upward direction and the box is also displaced in the upward direction. Another example, in tug of war, the work done by a winning team is positive. The winning team applies a force on the rope in the backward direction and the rope is also displaced in the direction of force applied. If theta is equals to 90 degrees, that is, if the force acts at right angles to the displacement s of the body, Fs cos 90 degrees. Since cos 90 degrees is 0, W is equals to 0. That there is no work done by the force. So it is called as 0 work done. For example, no work is done by the force acting at right angles to the displacement of the body. Now, for example, when a stone attached to a string is rotated in a horizontal circular path, the force acting on the stone is always towards the center of the circular path. Force is called as centripetal force or center-seeking force. Since the stone is displaced from the one position to another position of a circular path at right angle to the force acting on the stone, so work done on the stone is given by W is equals to F cos 90 degrees, that is Fs cos 90 degrees, that is equals to 0. Work done by a force of gravity on a box lying on the roof of a bus moving with a constant velocity on a straight road is 0. In this case, force of gravity acts vertically downward and the displacement of the box takes place horizontally. Now, if theta is equals to 180 degrees, the force just acts opposite to the displacement of the body. That is, W is equals to Fs cos 180 degrees. Since cos 180 degrees is minus 1, then the work done by the force is known as negative work done. Work done by a force on a body is said to be negative work done when the body is displaced in the direction opposite to the direction of the force. For example, when an object is lifted upward in a certain height, then the work done by a force of gravity on the object is negative. In this case, the force of gravity acts downward on the object and the object is displaced upward, so that the angle between the force of gravity and displacement of the object is 180 degrees. In tug of war, the work done by the losing team is negative. The losing team applies force on a rope in backward direction, but the rope is displaced in the forward direction. So if S is equals to 0, that is, the body does not move from its position on application of force, then W is equals to 0. Thus, no work is done by the force if it fails to displace the body. For example, when a person pushes a wall but fails to move the wall, then work done by the force on the wall is 0. Once again, the work done by a force may be positive or negative or 0. The work done by a force is positive if the force and displacement are in the same direction. The work done by a force is negative if the force and displacement are in opposite direction. The work done by a force is 0 if there is no displacement. The work done by a force is 0 if the force is perpendicular to the displacement. For example, when we lift an object, the object moves in upward direction of force. Here the work done is positive, but there is the force of gravity acting in the downward on the object. The work done by the force of gravity is negative. For example, a lifts a luggage of 15 kg from the ground and puts it on his head 1.5 meter above the ground. Calculate the work done by him on the luggage.